Hello everyone, I'm Pablo Armingol from Telefonica, and I'm going to present the work that we are doing in 3 projects, Int5Gent+, Allegro, and SEASON, and it's about a multi-layer slice controller architecture. I just start with the general architecture that we are planning to create with the main modules, and the process that we think is the most appropriate way to do this slice architecture. Functional architecture to see the slice visualization of this process. We start with a 3GPP request. So the first problem that we found is the connectivity with IETF format, because nowadays there's no way to translate from 3GPP slices to IETF slices. So solving this problem, we found that 3GPP doesn't not specify slicing capabilities. So that's why we changed to IETF and use the same format for the slices. Now the IETF is working on create a standard for the slices model, and we found these objectives to go. The connecting 3GPP with the IETF model, the mapping this process between 3GPP and the IETF network slices. They use a multi-layer path computation with IP and optical topologies, and have a vendor-agnostic multi-layer topology and a database to store all this information. So Telefonica, we in Telefonica are prototyping and demonstrating this architecture with TeraFlowSDN. The workflow that we present, starting with the 3GPP request, we need to translate it to the IETF slice to have the same model for all the slices. And the network slice controller needs to ask if it's possible to create a slice or no. So he will ask to the SLO module with path computation, multi-layer path computation, we check if it's possible to create the slices via IP topology, or if it's needed to mix IP and optical topologies. So if this slices is feasible to create, the SLO module answers yes, and the IP controller will create this slice. In Telefonica, we present this topology where the transport slice intent is the main module, which we divide in also 3 small modules: the mapper, realizer, and planner. I will explain this in detail in the next slices. The transport slice intent is the module which translates from 3GPP intent to IETF format, and it's possible create the slice with, in this case, the format of TeraFlowSDN controller. For this, we need to obtain the topology, the IP topology and optical topology, and the multi-layer topology database will be this module to retrieve this information. And TeraFlowSDN controller will be the IP controller and also the optical controller to communicate with all devices. For the IP architecture, we use this small topology that combine IP devices, physical devices with virtual devices. And I'm going to explain now the main modules of this architecture. As I explained, we'll start with the 3GPP intent. So the first step is to translate this to the IETF format, so the mapper can read this intent and manage this information. So the first step to doing the mapper is to check if this intent is possible to create a slice network. So the mapper will talk with the planner module and check this information with the path computation. If the mapper receives a yes for this question, he will send information to the realizer, and the realizer will manage this information, formatting it to the TeraFlowSDN format. So to check if this intent can be created, the planner uses a multi-layer path computation to combine IP and optical topologies and checks if the resources of the IP topology are enough or it's needed to combine with the optical. With this, we are exploring also artificial intelligence techniques to optimize the path computation algorithm. With TeraFlowSDN controller, we will export this information about the topology, the IP optical topology with an IETF format. So it's also with the same format as the intent, so it's easier to manage this information. And also for the slice creation, now there's a module in TeraFlow which can manage the slices, but we need to modify it to support these new functionalities. These use cases are based on the level 3 VPN creation, but it can be about the level 2 VPNs or other functionalities also. For the request process, in the 3GPP request, we obtain a lot of information of the service that we want to create. This is a way to explain what the user wants to create. So we can focus in the transport matrix, where we can see the public IP of the device, the interface, and the type of the interface. So we need to translate it to use this information. So the mapper receives the 3GPP request and sends it to the planner, which translates it to an easier way to manage the information with the topology. The first image, you can see the source and destination of all the links with the bandwidth capacity that it's worth. So for each intent, with the path computation, the planner check if it's possible and create all the slices that is needed to create the level 3 VPN in this case. So in the second image, we can see that we need to create the 2 slices to create a level 3 VPN. As we can see, the planner answered to the mapper, yes, you can create the intent. So the mapper talk with the realizer, send the information, and now it's the realizer needs to format this information with the TeraFlowSDN control format. So in the endpoint box, we can see that it changed from the IP, public IP to the real name of the device in the topology. So it's easier to the user to follow this information and know what is happening in its domain. For these slices, we are focusing in the bandwidth configuration. So in the slide requirement box, you can see that the capacity and the isolation are 0. The capacity, so the availability and the isolation are 0 because you are only configuring the bandwidth, but if the use case is different, these parameters will change. And when we have the transport slice with the TeraFlow format, we can communicate with TeraFlow, send the intent, and configure the services. This is at the left image, we can see what the web UI of TeraFlow shows to the users, showing all the details of the slices. So the devices are in the service with the parameters that we need to configure in each case. Or configure this slice, the user in this case is the realizer, so to TeraFlow checks if there's any slice with these requirements for grouping it, and don't create another if it's not necessary. And in case that it needs more resources, TeraFlow will create another slice. For the functional architecture, we start collecting all the information about the topology. Now, this is a static way of obtaining this information. We are working on export this information with the IETF format, but we use the topology information in a JSON file with the TeraFlow, with the expected TeraFlow information. This is the same for the IP and the optical topologies. This information is sent to the transport slice intent and to the planner component to do the multiplier path computation algorithm. Here we have a representation of the topology, having the IP and the optical topologies combining with the information. As I explained, this is static information, but we are working on how to dynamically, and it can change in everything. This is the process when we send our request. The planner check if we can create the route. In this case, we have different bandwidth availability in the different links. So we create a new path with these resources. In the case that the IP topology doesn't have enough resources, we need to combine with the optical topology. So for the IP, it appears like a new link between the IP nodes, but we are going through the optical topology. Later, I will explain in more detail in the demo. So with this, we can see how the slice is going to create the level 3 VPN channel and all the nodes that are involved in the communication. Here we have the example of the information that retrieve the planner with all the nodes and the steps that is needed to create. And we are also working in the segment routing policies. By the moment we create an ID for each segment routing policy, but the idea is having a database with the relationship of each number to the real routing policy. So TeraFlow can connect to this database and know what to configure in each device instead of sending a lot of information to TeraFlow. That's all. If there's any question before.
On the slide number 9, you talked about mapping between the NGPP data model to the IETF transport network. Is there any visual information that is either lost in the mapping process? Because as far as I know, the NGPP slice, the data model is quite big. And do you map all the informations within the IETF transport slice data model, or some of them are not lost or somehow?
This is only information that we receive from 3GPP.
Okay.
And we only focus on this information that we have the interfaces of the node and the node. So the planner matches the public IP addresses of the node, changes to the name of the node in the topology, and creates the path computation algorithm. So the rest of the parameters, we discard it because we only focus on this.
Okay.
The use profile to create the segment routing policies and the name of the node.
Thank you.
Another question. In remember the slide number, but the slide will present the overall architecture with the
This?
this one. If I understood well, You mentioned that you plan to use the TeraFlow for the IP controller and the optical controller, right?
Yes.
But for the upper block, are you considering maybe to use TeraFlow at least for some of the boxes, or is everything separated from your view?
Maybe we can integrate a multi-layer topology database in TeraFlow, because if we are using TeraFlow for IP controller and optical controller, we can have a common database with all the topology.
Yes, because there are other projects that are considered also using TeraFlow for end-to-end. If we wrong, or we will have a presentation for the afternoon. Maybe we might try to align also things. For sure, if there is here some specific block, I understand there is some part that might be, in this case, Telefonica proprietary, I don't know. But even if there is some proprietary part or something that is not, that will not be contributed, I think it might be interesting to have, I mean, to improve the multi-layer support of TeraFlow with your processes.
Yes. The idea is this. By the moment we have all out of TeraFlow, I think the future we are planning to move these boxes inside TeraFlow. For example, the planner algorithm, move it to path computation box inside of TeraFlow.
For instance,
So in this case, we don't need the communication with the multi-layer topology with all the transport slice intent, because all of this will be in TeraFlow. So we don't need the external communication because it's in the same. So.
Just out of curiosity, which version of the slicing the specification used?
I don't know. Of this. If there's no more questions, I can go to the demo time.
For changing the screen.
Yes, please.
Maybe you can just connect it. Yeah.
In
Mhm.
Slack. Into Teams. That is risky.
Vamos a compartir ahora la pantalla. Okay. That's it.
Okay, so as I explained, for the topology information, we are using a static JSON file, but this information is the same as TeraFlow is expected to export. So in the future, this information will be exported by TeraFlow and will be dynamically updated. This is the same for the IP topology as the optical topology. So when we launch the planner module, we load the topology with all the information about the nodes and the links. We create a graphical view of this topology in which we can see the optical information mapping with the IP information. We click in each node, we can see in the IPs all the interfaces, and in the optical devices the same with the lambdas for each channel. So if with the 3GPP intent, if we want to create a slice between the HL412 and HL522, we process the information In the QoS profile, we have the bandwidth requirements. In this case, I said this is their bandwidth of each link. So I'm going to set 6 GB. So in the first time that we want to create the path, we have this path with the 3 nodes and the bandwidth information in the links update. So we go from 10 GB to 4 GB. If we want to create the next slice again, we change the path. Also update the link bandwidth capacity. And if we want to create the third slice, now it fails because we need to combine IP with optical topologies. In this case, in the IP layer, we will see a new link between this node and this node, but really we are going from the IP to the optical, the links that it's defined in the optical topology, and again going to the IP layer. I didn't explain this, but in the IP layer, we only see one link because it's bidirectional, and the optical we can see two because it's unidirectional, because there's 2 links bidirectional. So that's the demo. We want to present a graphical view of how the path computation algorithm works and how it updates the information in the real topology. So the next step is to connect this with TeraFlow to send the slices and create all the services in the topology.
Demonstration is right now standalone.
Yes.
The connection with TeraFlow is still work in progress.
Yes.
Okay.
Because there's some parameters in the TeraFlow slices that must be user agnostic. So we are working on it to the users, because the user really don't need the IP to the new interface that is going to create, for example. It's work of TeraFlow, not the user. We are optimizing this. So this is the next way to finish this. If there's any question,